thank you very much for being available. And then over to you. You can make your slides available from your side. Everyone can see the screen as you see at the top there. Over to you. Thank you.
Okay, thank you, Prof. Kirsten. So we want to make sure the methodology is correct. That's very, very important, and your design before you go and gather your data. If there's any questions, if you can please let Prof. Kirsten know, and then he can maybe tell me the question and I can answer it for you. If that is fine.
It's fine. It's fine. We'll do that.
Okay. Okay, we'll do a quick introduction, then we'll look at the research process, then we'll look at research questions and hypotheses, then research methodology, gathering data, then format of the data, what must the format of the data be, data coding, a little bit about statistical packages, and just very quickly, what is the data analysis cycle? Okay, just the introduction. I'm from Liminal Research Consult. That's a company, we do statistical analysis. I'm a statistician. What is very, very important, you must, before you gather your data, we want to make sure that we can do the analysis, so everything must be in place for the analysis. So that's what the whole point of this whole workshop will be. Okay. Okay, we first look at the research process. Let me just see if the diagram, okay, sorry, let me just go back one here. Okay, we'll use a diagram to just show the research process, just to get the setup on what we will be talking about. Can you see this diagram, all of you?
Yes.
Okay, the first step, that's the problem discovery and statement. This where we have our research questions, hypothesis, objectives. We set the delimitations, the assumptions we make. Then we have our theory, which is the second step, the contextualization, the literature review. And then we go into the research methodology. And there we decide on a research method, qualitative, quantitative, or a mixed method approach. And then there's a few designs. You can see here, can you see my mouse?
Yes, yeah, okay. We can see it.
Okay, then let me just make it. Okay, can you see the pointer? At experiment, can you see it? Is it not showing?
It shows, yeah, it shows.
Okay. Okay, then you look at the research methods. I just want to point out quantitative, you get experiments, but also surveys. So quantitative could also be surveys here. Even secondary data could also be quantitative. Then we'll look at the research approaches. Then we look at a sample here. And then we look at formatting, editing, coding of data, data processing. Then when we do our interpretation, we go back to the literature. Okay, so that's the research process. Okay, you're all fine with that?
It's a very useful diagram, thanks.
Okay, can we go on from here? Okay, to start with the research questions and hypotheses, you need to have a starting point. So your research questions and hypotheses guide your research, okay? It gives you also a starting point for the analysis. So when we do the analysis, we start with the research questions. Okay. Then your title, your research questions and hypotheses must be linked to the title directly. Sometimes students forget about that. Your title is actually what it's all about. So you must have a link between the research questions and the title. You must actually explore it with the research questions and hypotheses. You're all fine with that? Okay, the research questions. What's the difference between the research question and the hypothesis? Can some of you tell me? Is there somebody that wants to tell me?
Who wants to say something? I think they want you to say.
Okay. Okay.
Anyone? The difference between hypothesis and the question, research question.
Research question is sometimes like you have it's like what you want to solve, the problem you want to solve. This is in the form of a test. Hypothesis is an assumption that you want to find out whether at the end of your research, whether you'll be able to validate that assumption.
Yeah.
To find out whether your research process, but your findings, you take your findings to see whether the assumption you make earlier is true or not. So it's an assumption.
Did you hear all of that?
Yes, I got it. Thank you. Yes. So a research question is more broad. So you set your research question and you want to try to answer it. And then your hypothesis is more specific. So you want to test a hypothesis. So that's more specific. The research question is more broad, something that you want to investigate. So you can have your research questions and then you can have specific hypotheses that you want to answer. Okay? So if you go to the research hypothesis, it's a specific statement that you want to disprove. Okay, so what's important with a hypothesis, there's three things about the hypothesis. The first thing is the variables in your hypothesis must be measurable. Okay? Then the hypothesis must be testable. That's usually testable with a statistical test. And then the third thing, it must be falsifiable. So you must be able to disprove it. So that's the three things that must be in place for a hypothesis to be a research hypothesis. You're fine with that?
Yeah.
And you can use both hypotheses and research questions. But research questions is more broad. You can even have research questions and do statistical analysis without hypotheses. Because say, for instance, you do a statistical model, you can investigate something and then look at a model and there's measures of model fit. So you're not necessarily go and disprove something. You fine with that?
Yes.
Okay. Okay, research methodology. So now we'll look at the research methodology. So this was all part of the problem statement. Now we look at the research methodology. We look at research approaches. We look at research design. We look at experimental design a little bit. Then we look at the research instrument. In quantitative research is the questionnaire. Then we look at the research consistency matrix. That's a matrix that I use to make sure everything is aligned, what Prof. Kirsten was talking about in the beginning, to align everything, your research questions, the questionnaire, and the analysis. This is what the research consistency matrix is used for. Okay. Then we look at the population and sampling a little bit, sample size a little bit. Okay, is that fine? This is all part of research methodology. So it's your research design, your instrument, and the sampling. Any question?
Well, yeah. So you can just go on, and if there's a question, I will interrupt you.
Okay, that's fine. Okay, let us look at the research approaches. The first approach is quantitative research. Quan. Now, okay, I'll get to that later. Then you get qualitative research with the interviews, and then you get the mixed method. Now, what's important here to understand is you can have quantitative research with a capital Q-U-A-N with a little bit of qualitative. Say, for instance, you have a questionnaire and you have comments that you analyze and you look at themes. Then there's a little bit of qualitative just to inform the quant. But it's not a mixed method in this case. The main approach here is quant. Okay. Then you can have qualitative with your interview, say there's 15 interviews, and just report descriptive statistics with a little bit of quant. But mainly it's qualitative. So everything you want to prove or look at is qualitatively based, the weight of it. It's just a little bit of quant. But then the mixed method, you must do both approaches thoroughly. So you do, say, the questionnaire here for quantitative, and you do for qualitative, you do the interviews. So you do both thoroughly. You fine with that?
Yeah, just ask the question.
Yes.
Question.
100, what is it 100 by 100? Is it 100
Yes.
or 100? Does it mean that if you are being quantitative, if your sample sizes, or maybe the number of respondents is say 100, maybe 100, does it mean that with the qualitative, the number of people that you are going to interview, that's the respondent, is also going to be 100? Is that what it means?
I think it refers to 100%.
100%, yes, 100%. Sorry, there must be more specific here.
Yeah, it's not a number of participants.
Yes, it's 100%. So you must do both approaches fully. You cannot even do it 50%. You must follow both approaches thoroughly. You fine with that? Yeah. If we can get to a number, just a rule of thumb, if it's above 30, then you can do something quantitative, but that's really scraping the barrel. But everything below 30 of your population is not viable to do any quantitative study. Okay. Quantitative studies is in the region of 100 plus or 300, that region. Okay, you fine with that? Okay, what I want to do is I want to explain, but I'm trying to write, but it will be a bit difficult. Let me try. Can I just try to set up the something here to try to write? If you just give me half a minute quickly.
Sure.
Please. What we look at now is the way you do the mixed method approach. So there's 3 different ways that you can do the mixed method approach. I want to look at that, but I want to explain it to you by writing. Okay, I just want to share.
So if I look at this whole thing, while you're busy,
Yes.
The quantitative, the top one will be mostly positivistic research. And the second one will mostly be interpretative research. But like in the third one, it's almost like having 2 different studies.
Post-positivist?
Post-positivist leans towards interpretivism, but it's a very vague concept in my mind. Interpretivism is a better way of looking at post-positivism. Post-positivism, I've seen a lot in the management disciplines, but in the IS discipline, it's interpretivism or positivism. So what I think what Danny is demonstrating there in the first one, it's actually positivistic research mostly. Second one, mostly interpretivist research. And then the third one will be a combination, like two separate studies answering different questions in different ways.
Okay, I'm ready for, can you see on the screen the whiteboard I'm writing here?
Yes.
Okay. Okay, let me just take that out. Okay, so if you look at the approaches, you first get the concurrent approach. So you'll have the quant, and the qual at the same time. Both of them at the same time. So what is important here is with the quant and with the qual, you'll have themes for qualitative, I presume. And then for quantitative, say you have themes. Say for instance, you're looking at the technology acceptance model that they use to look at new technology. And the technology acceptance model, you get ease of use, usefulness, intention, attitude. Now, if you would have done it with the two approaches, you know there's 4 different constructs here. So ease of use, usefulness, and then intention and attitude. And from the qual, you must integrate these 2 with each other. Because in the end, when you write up, you want to say something about both. So when you do the concurrent approach, you must make sure from the beginning that this themes is aligned from the 2 approaches. This themes here and this constructs here. You fine with that?
Yeah. So then in the qualitative case, you will collect through interviews, for example, and quant you will collect through a survey or an experiment.
Yes, yes. But what is very important is, say in the qualitative, then you must make sure your interview is set up in such a way that you'll be able to get, say, the 4 constructs, if you aim for that. And then in the quant, you must specifically have questions for each of these constructs in your questionnaire. So the 2 approaches is aligned from the beginning. Otherwise, say for instance, in the quant, you forget to say something about, say, attitude. Then you will not measure it, and then you cannot say something about it, and you cannot compare the 2. But it happens sometimes, say in the qual, there can be other things coming out, then you must just talk about it. But the main issues you want to compare with each other, the main constructs. You fine with that? Okay, so that's the concurrent approach. Okay. Can you see my handwriting?
Yeah, that's fine. It's fine.
Okay. Okay. Then then you get, it's a concurrent approach. Then you get the sequential approach. Sequential approach. So say you can start with qual first, and then you do quant. So what you'll do with the qual here is you'll use these interviews to create the questionnaire. Okay, so you use the interviews from the qual to create a questionnaire for the quant. So say for instance, if you're not sure and you don't have a validated questionnaire and it's really exploratory, then you can start with the qual study, do it thoroughly, and then from these themes here, you develop Likert scale statements and you can use it in the quantitative, and then you send out the questionnaire in the quantitative, and then, but what you must remember is you must still test the quantitative for validity and all of that. But what it will help you with is you'll get your questionnaire from the qual. Any questions on this?
Makes a lot of sense.
Okay. Okay, then the other sequential approach. You start with the, you start with the quant. And then you do the qual. So, but you must be sure at this stage here with the quant that you know what's going on, you know the constructs. You have a questionnaire already available. So then you test it with the quant, you look at patterns here. So you do the analysis and you look at patterns and trends from the quantitative analysis. And then you use the qualitative interviews to inform you the patterns that came from the quant. So say for instance, you got strange phenomena, then you can explain it with the qualitative. Or if there's a general pattern coming through, you can sort of confirm it with the qualitative interview. So it gives you a bit more richness on the quantitative. You
So,
find, yes.
Yeah. Okay, there's one question. Yes.
Yes.
I want to know which of them is exploratory and which of them is explanatory.
The question is exploratory. Which one is exploratory and which one is explanatory? Is there
Okay.
a way to
With qualitative, I will not know what is explanatory or exploratory. With quantitative, say for instance, if you look at the first approach, then the quantitative could be, the focus is more on the exploratory. The second one, it's not confirmatory. It's not confirmatory. We look at confirmatory in quantitative thoroughly, because for the confirmatory approach, a lot of things must be in place. But for this first sequential method or strategy, exploratory, it will be more exploratory in a sense, because you're not sure what's going on. The second strategy, you'll know what's going on, but not necessarily explanatory from a quantitative point of view, not necessary.
So from a qualitative perspective, explain and explore, you can do it with qualitative research, any one of those two.
Yeah.
It just depends what sort of research question you start off with.
Yeah.
In terms of these two sequential approaches, yesterday we spoke about inductive reasoning and deductive reasoning.
Yes.
With deductive reasoning says you start with some sort of theoretical framework, and it fits well with the second one, which means you've got a theory, you do your quantitative data analysis, and then you try to explore the detail and the intricacies with qualitative. While with inductive, which is often a useful approach in an environment where little research has been done, in a unique context, you start with a qualitative.
Yeah.
Then it's inductive, because you try to understand what goes on there, and then in the quant, which follows, you try to interpret, to assist you with the interpretation of what you got from the qualitative interviews.
Yes, yes, I agree.
For example, in our contest, assuming if you want to do a research on maybe student experience on maybe any system like e-learning or ODL or anything like that, you have to start? You can start with a qualitative aspect. Get some overview about this before you go ahead to design the question to do the quantitative.
Yes.
Is that
Yes.
what I'm getting?
Yeah.
So in that case, that is the deductive approach.
Yes.
You start qualitative.
Yes.
It's inductive.
It's
inductive.
Yeah.
You basically let the data tell you which theory will fit well.
Yeah.
That is inductive.
Inductive.
Yeah.
Okay, you can.
Yeah, no, that makes sense. That makes sense. So the second approach would be more leaning towards confirmatory, and the first one more towards exploratory. But we'll talk about that later. With quantitative to be explanatory, there must be a lot of things in place. So even if you know the constructs and you do the analysis and all of that, it's not necessarily explanatory in quantitative, because it's very strict in quantitative. Okay, you're fine with that?
Yes, sure.
Okay, no further questions on the two approaches. But this mixed method approaches is very, very valuable. It takes a lot of time, but it's very valuable to do mixed method research. Okay.
Very good. Yeah.
Okay, okay, I must just get back to.
There's a couple of people who understand the mixed method has done it. Yeah, like Ismail, you want to do it. Yeah, so thanks.
No, pleasure. Yeah, with the industry, when we do large projects and we work with qualitative researchers, then we do follow the mixed method approach. Otherwise, you cannot just use one approach; it will not work. Okay. Let me just go back. Can you see my? Sorry, I just want to.
I think you made mention of 3 major types under the mixed method.
3 major types.
Yeah, like approaches that you can employ.
Yeah, it's the quant, and then qual, and then the 100.
And then the mixed under the mixed method, you made mention of the mix. Because I got the impression on the mixed method,
just
on the
Yes.
concurrent.
That was it that will be quantitative, but there's a little quantitative.
Yeah.
That's what we need to
I got that one, but under the mixed method, how you can approach it. That's where you made mention of the sequential and the concurrent one. So you
yes.
made mention that there are 3
Yes, okay.
aspects. So I was thinking you touched on the last one.
Did you get the question, Laini?
Sort of. Just come. You can come in there a bit.
So the question is that Manuel, he understands that there's a quant and then a qual, and then it's the 50-50 or the 100-100.
Yeah.
But then he said under mixed method, you said there's 3 approaches, and you said this concurrent and the 2 sequential.
Yeah.
Yes,
So
two sequential and 1 concurrent. The ways that you implement the mixed method.
So you just keep.
There's three ways to yeah.
This
Is it this 3 ways? Is it implementation
Of the mixed.
Yes.
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 Yeah. Okay. Yeah.
Yes. So concurrent and then 2 sequential ways.
Could you maybe go?
Oh, okay. There are 2 sequential ways.
Yes.
Okay.
Yes. Okay.
Yeah. Let me just recap on that. Can I recap on that quickly?
Yes, please. Yeah.
Okay. Let me just share again here. Okay. Sorry. This thing. You know the computer. It's not. Sorry. Let me just try again. It doesn't want to share now.
Should you not first unshare?
Let me just stop and try again. The computer is shy now. It doesn't want to share with you. Let me just plug it in again. It's okay. Okay, can you see now?
Yeah.
Good. Okay, so the first approach is concurrent. So we can say it's qual, quant together at the same time. Okay? So it's the same time you do this. So you must make sure you integrate from the beginning. Okay? Then you get the sequential approaches or ways to implement it. You first have the qual. So you explore here with your interview, so you develop your questionnaire. And then you have the quant. Sorry, this one is a bit, sorry. And then this is the A and B. You have the quant informing the qual. So here you have your questionnaire already, and you look at patterns, and then you talk about the patterns in the interviews. You're fine with this?
Yes. Does that make sense?
Yeah.
Good. Thank you.
Okay. Great.
I don't know if you can go over the concurrent. It's like you mentioned some ingredients there that you need to integrate.
Okay, so there's a question in here on the integration aspect of the concurrent approach.
Yes.
What do you mean by that? Integrate? How? What do you mean?
Oh,
by
okay. Okay, like I explained, let me just go back to that. Can you see? I'm not sure. You see my screen?
I do. We do.
Okay. Okay, so if you look at this integrate here, you want to integrate or compare your results. So say for instance, you have A, B, and C, that's your themes, and A, B, and C here. You want to be able to explain how this all relates to each other. So say for instance, you investigate the technology acceptance, like I said, in qual. If you miss something there in qual, you will not be able to say something about it when you compare it with the quant. Say for instance, ease of use, and you forgot to ask something in the qual about ease of use in the interviews, but it's in the questionnaire in the quant, then you cannot, when you explain the results, you cannot compare the two. You can only talk then about it from the quantitative point of view. So you must try to make sure everything is in both approaches. It's not perfectly possible always, because from the qual something can jump out, but then you explain it. You're fine with that?
Thanks.
Okay, can we go on?
Yes, please.
Okay. Let me just go to, can you see the PowerPoint again?
Not yet.
Okay. Okay, let me just, okay, I've closed the other one. Let me just open it again. Can you see it now?
Yes.
Okay. Okay, that's good. Yeah, we do it over a distance now, so it takes a bit of time to jump around between the whiteboard and the PowerPoint. Sorry for that. Okay, so now you know what's the approach that you want to follow. So the second step, I'm just talking about the quant now, is to decide on your research design. So what research design do you want to follow? So what will inform you will be your research goal. So your research goal, you'll decide on your research goal, and that will inform the research design that you choose. Okay? So if you follow exploratory research, but remember I'm talking about quantitative now, so don't get confused between quant and qual for now. So for quantitative research, when your goal is exploratory, you follow a descriptive research design, we'll look at that, or you can follow a correlational design. But then if it's explanatory in quantitative, you follow experimental design. Fine with that? So your goal will inform which research design you follow. Or you can look at your research objective. If it's exploratory research, you follow this approaches here. Or if it's confirmatory research, you can follow one of these designs.
So if I can just maybe try to explain and confirm, maybe you can check if I have it correct here.
Yes.
Descriptive design basically says it's about what is out there. Experimental design is where you've got a control group.
Yeah.
Where you introduce technology to the one but not to the other, and then you see the outcome.
Yeah. Yeah.
Okay.
Yeah. Yeah. Let me. I will talk about it. Let me just see if it's in. Yeah, it's in the next slides. Yeah. Yes. So for quantitative, it's very strict to be explanatory. Usually it's only experimental design that you can use to when you do explanatory research. Sometimes they use structure equation models and they say it's explanatory, but there's a bit of not everybody agrees on that. Okay. Okay, let us go to the different research designs. So you decide on a goal and then you choose the type of design. Now, there's a lot of different research designs. I just look at the three main types of designs. Okay, the first one, like Prof. Kirsten said, descriptive design. You just want to describe the current situation. That's all you do. So usually you'll do descriptive statistics. You can do a little bit of statistical tests, but your main focus will be to describe. That's what you do here. That's when it's descriptive research, design.
Yeah.
Yes.
I noticed something, the descriptive. In most cases, you submit papers when the design is more descriptive and the results are descriptive. It's not powerful enough. People always tend out to question it because you can easily cook it. Especially for PhDs and I don't know. But sometimes the descriptive data also contains some level of relevance that maybe you need it, but you submit it in your PhD or you publish it, they tell you it's rubbish because anybody can cook that data. Yeah. So how do we balance it?
Yeah, to keep the externals happy. If it's a descriptive design, say for instance, I want to describe level of stress. And now I make sure I measure stress thoroughly, and then I describe this is the level of stress. Then I can just look at it a little bit from different angles. Say for instance, stress between males and females. So then I do a statistical test, a t-test. So then there's some inference involved, but you still describe what's going on. So the main issue is still describing, not looking at differences, but you can use that to explore a little bit more. So then at least you have statistical tests that goes with this descriptive. I don't know if that, yes.
We can use that one to handle the elementary, like the bio data and then the demographics and
but you have to have a follow-up.
Yes.
Yeah.
All right.
Yeah. Yeah. And then I think what would be the important part here, and this is what people miss a lot of times, is make sure you have an instrument that measures thoroughly, and rather make sure that's perfectly in place, and then you describe this is the level of stress. Then you did the contribution instead of going to the complex models, but you don't measure thoroughly. So make sure you measure thoroughly, and then when you do a descriptive design, then there's still value in that. Okay. You fine with that? Okay, can we go on? Okay, the next one is the correlational design. Now, it's not a correlation in statistics. They just call it correlational design, but it actually means relationships. So now your main focus is looking at the relationship. So in your title, usually there will be something like, I'm comparing this to that, or this is influencing that. So that's a correlational design. So you look at discovering relationships among variables. So then you can do a lot of complex statistical analysis here, but it's still exploratory design, exploratory a goal with a correlational design. You fine with that? Okay, then the next one is the experimental design. So then you use an experiment to look at the influence of a manipulation or an intervention. Okay. Then usually you'll have a control group. We'll look at the experimental design a little bit. So you can have an experimental design with a questionnaire as your instrument. A questionnaire as the instrument. Okay, you fine with that? Can we go on with experimental design?
Please,
Yes.
can you come on the experimental?
Yeah, you will get to that.
Sorry?
You can go on.
Okay. Okay, experimental design. I will not look at it. There's a lot of different experimental designs and it's a field on its own. I will just look at one or two things and where you can use a questionnaire together with an experimental design. So what we'll look at is we'll look at repeated measurements. So we'll look at pre and post groups and we will look at a control. You fine with that? Okay, let me just explain first. Let me just go to the board again. Can you see the, is it sharing or?
No, not yet.
Okay. Okay, is it there? Okay, if you look at the pre and a post, you'll have some intervention here in between. So say if we look at repeated measure designs, we have a pre and a post measure and then in between there's some intervention. Say for instance, you want to see the effect of chess instruction. So you provide chess instruction to children in school and see if it improves, helps them improving their marks. So then the intervention is the chess instruction. And then you measure it pre and post. And then in between, after the pre, you do chess instruction for a few weeks. Now, what is important here is, and I'm talking about the design perspective here. You must be able to measure the person pre and post and be able to link the two. So you must have some sort of unique ID at pre and the same ID at post. You can use an ID that's anonymous, but you must be able to link the two. Otherwise, you'll not be able to do the analysis. Then the next thing is you want to have a control. So let me just take this off. Okay, can you tell me why do you need to control? There's somebody. Why do you need to control?
Because we need to moderate the pre and the post. Something that can moderate it more or less to check the imbalances among it, so more or less access like a moderation sitting between the to check.
Okay, we will get to moderation and mediation a little bit later and control variables, but this is not exactly the same as a control variable. So what you use here is you use it as a control group. Can you all see there? Control group. And then you have the treatment group. Oh, sorry. the treatment group. Then the control group don't get the intervention. The treatment group get the intervention. So for the control group, they don't get chess instruction. The treatment group get the chess instruction, for instance. Now, what you want to see is, if you look at the graph, and you look at pre, and you look at post, and there's the two groups. Say this is the control group, and this is the treatment group. And then afterwards, you test them again. Say something like that. So what you want to see is, you want to see what is this improvement here, this improvement there. So you want this treatment group, you can see it goes up a lot, and the control group sort of just improved a little bit. So you want to see the improvement over and above the control group. So say, for instance, in a school setting, if you look at school children, then they get exposed to a lot of things. Even the control group get exposed to other ways they learn. So they will still improve, but the treatment group improve much more. So that's why you need a control group. So you want to see that improvement over and above the control. You can see the control here just improves a little bit, but the treatment improves a lot if you look at the two slopes. You fine with that?
Yes.
Then from the experimental design perspective, because we're busy with design, here at the at this stage here, you don't want a significant difference between the two groups. So say, for instance, you don't want to have the control group, say in this case, this control group is significantly better. No, say the treatment group was significantly better than the control group. Then you have the better students in the treatment group, and that will give them advantage. So you don't want to have that. So when you do your experimental design, usually you make sure that you assign it randomly, but that's not possible always. So then it's a quasi-experimental design. But you don't want to have biasness in there at least. So you can't go and give it to all the smart people for the treatment group. Okay, you fine with that? Okay, can we go to the back to the slides? Can you see the slides again?
Yes.
Okay. Okay, so what I was talking about was this link between the pre and the post. So there's the subject ID. So you see this person, 1543. Say, for instance, you measure stress. You measure it before, and then there's some sort of intervention, and then you measure it afterwards. So this 80 here was for this first person, and then this person's stress level went down to 65. In the analysis, we'll say subtract this from that. So then we get less stress. Or sometimes you fine with that? If you're not able to ID this two, to link the two, then we cannot subtract the two from each other. You fine with that? Some people make the error to think that you have your group before and you have your group afterwards, and you then can just compare the two groups with each other, say like the average. But you need this link because we want to take it further. Okay, then we talked about this just now. So say, for instance, you look at student marks and you look at this chess instruction. So there's the pre for both the treatment and the experimental group. So the experimental group got the instruction. And then you can see the control went up a little bit, but the experimental went up a lot. So this improvement here is what you're looking at when you do the analysis. Okay. Fine with that?
Yes.
Okay, so from a design perspective, remember the link and remember the control group. And randomize here, or at least have the groups, not biasness in the groups when you assign the people. Okay, any questions so far?
No.
Okay, so we looked at experimental design very quickly. So the next thing we want to look at now is the questionnaire, which is your research instrument. So the questionnaire is a research instrument consisting of a series of questions. So usually you'll have your biographical information that can give you the characteristics of your sample. And then you have scales. We'll talk about that thoroughly. Scales that gives you construct scores. And then you can have some yes and no questions and even some open-ended questions. You all fine with that? Okay, I talked about the structure of the questionnaire just now. So you have your biographical information. Okay, let me ask you a question. Where do you put your biographical information, in front or at the back? Where do you put it? Can anyone tell me?
This questionnaire is valid. How do you know?
Sorry?
Yeah, you're actually asking another
Yeah, how do you
question.
know? I didn't get the question.
The question is, where do you put your biographic data, in the front or in the back of the questionnaire?
Yes.
Where do you put
Your biographic data.
before
or after in the questionnaire?
Before.
Answer is before. What do you say?
Okay. Okay, so there's two schools of thought. Usually it's in front. So the advantage of this would be you will be making sure you get that information, because sometimes when people fill in the questionnaires, maybe at the end they skip one or two questions, the biographical information. But sometimes in psychology, for instance, when they do research that's more sensitive, say gender research, for instance, then they don't ask the biographical information before they put it at the back, because they don't want the people to think about, say, gender, for instance.
Oh,
Okay, does that make sense?
Yeah. So again, it's about what does your research question and your goal say about how to use the questionnaire.
Yes.
So
Yes.
I was asking, how do you know that this questionnaire is valid?
The question is, how do you know that the questionnaire is...
Okay, we'll look at that thoroughly. That's very, very important. We'll look at that thoroughly. Okay. What we will talk about is the scales in the questionnaire. The scales. Let me just... Okay, do you all know what is it? Or let me just write again. It will make more sense if I write. Sorry, let me just write again to explain scales. Oh, sorry. I don't know why the iPad is all the time, it's losing the connection. I don't know why. Can you see it on your screen? Okay, let me just share again.
Yes.
Okay. Okay, when I talk about a scale, okay, there's a bit of confusion here. When I talk about the scale, the psychologists talk about, say, personality scales, for instance. So that's what I'm talking about. So a scale consists of different constructs. And this construct consists of Likert scale. Oh, sorry. Likert scale statements. So you have a statement and then you agree, strongly disagree, all of that. So that's your Likert scale statement. So that's the items that forms part of the constructs, and then the constructs form part of the scale. So if you look at the technology acceptance model, for instance, TAM, this could be considered as a scale, measuring acceptance of new technology. Then the scale consists of constructs, and then the TAM model, you get the ease of use, for instance, and then usefulness. That's all constructs. And then for each of these constructs, you get Likert scale statements. So say, for instance, I have ease of use as the construct. And then I have a few Likert scale questions that I ask about the ease of use. You all fine with this?
Yeah.
This construct I'm talking about here, sometimes they call it factors, they call it themes, they call it dimensions of the scale. There's different ways to look at it. Okay. Then you can also get a scale that's a sort of a main scale that you don't look at the individual constructs anymore, you just measure one thing. Say, for instance, if it's stress, you just look at stress, you don't look at the individual constructs. But at this stage, you must just be sure with what is a scale, the constructs, and it consists of Likert scale statements. Okay. Okay, so now what we want to have is a valid questionnaire. So it's actually a valid scale in your questionnaire. So say, for instance, you have your technology acceptance scale that you measure, or say you measure performance, you have a performance scale in your questionnaire, that's section A. Then section B is maybe a stress scale that you investigate. You fine with that? So then the scale must be valid, the constructs of the scale must be valid, and it must be reliable. Now let us go to a example. I just want to open an article for you. Yes. I'm sorry, you have a question?
No, he was just commenting on something.
Oh, okay. To explain this validation, let us look at the article. Can you see the article on the screen?
I have shared it with everyone as well.
Oh, okay, that's good. Okay, can you see that on the screen?
Yes. Yes.
Okay, so to validate a scale statistically, you do exploratory factor analysis as a first step. Confirmatory factor analysis is the second step. There's a whole process that can be followed. But the first step is usually exploratory factor analysis. So in this case, they talk about the latent constructs. They want to measure public sector innovation performance. So we use exploratory factor analysis here to do the validation of public sector innovation performance. Now let us just go to one specific example. Then it will make more sense. Innovation capability. You all see this here?
Yeah.
Innovation capabilities.
Yeah.
Now, what we want to make sure is, we want to make sure, are we really measuring what we're supposed to measure? So what does that mean? Is the constructs of innovation capabilities valid? Is that what we're supposed to measure? Okay. So we want to make sure we're really measuring what we're supposed to measure. So what we'll do is we'll have a lot of Likert scale statements on innovation capabilities. So there's 29 Likert scale statements, and that's all about innovation capabilities. Now we do the factor analysis, and then from the factor analysis, we'll get constructs that's valid. Now, maybe I must explain the factor analysis first. Can I explain that first to you before we go to this here? Okay, sorry, I must just go to the quickly share the whiteboard. Okay, let me just share again. Okay, can you see it? Okay. Okay, so exploratory factor analysis. EFI. There's two steps. The first step is how many factors or constructs. Okay, that's the first step. So we must decide on how many. So we have this 29 Likert scale statements, and it was all about innovation capability. So we want to see how many factors do we get from this 29. That's the first step in the factor analysis. We have different criteria. I don't want to go into all the detail, but we'll quickly talk about it. You get eigenvalues. That must be more than 1. And then the cumulative percentage of variance must be more than 60%. And then you get the scree plot. So we'll have these 3 different criteria to inform us on how many factors there will be. Now this is exploratory, so it's not a fixed thing. So say for instance you get to 5 factors or 6, you'll try the most factors and then you look at the factor loadings, if you can interpret it, and then you work downwards. So this is not a fixed thing. So say for instance we get 5 here. Then the next step would be what? What is this factors now? That's the next step. And for that we get factor loadings. And we get the absolute value above 0.4. So this factor loadings will tell us where do the specific Likert scale statement load. Say for instance we have, say there's one, let me just write 3 Likert scale questions and say there's some factors here.
The factor loading should be greater than 0.4.
Sorry?
I mean that the factor load is
Yes.
greater than, should be greater than 0.4.
Yes, yes. Yes, yes. Yes, greater than 4. Okay, so say for instance this is a Likert scale statement here, this one here. So say it loads 0.8 here, and there's 0.1, it doesn't add up to 1 always. And this one is say 0.15. So you can see it loads here. This one is 0.6, say this 0.2 and 0.3, it loads here. And then this one is 0.3, 0.5, 0.2. So it loads here. So the factor loading will tell us this specific statement here. Where does it load on which factor? And this factors is the factors we got there. So now you look at this here and you interpret it. Okay, so let us go back to the, let me just switch to the, quickly switch to the desktop. Can you see the article?
Yes, yeah.
Okay, so I talked about this criteria here first. So you'll see there's the criteria. Okay, no, sorry, this is different, something different. Let me just see, where's the criteria? Yeah. You see, they said they extracted 5 components with eigenvalues greater than 1, and the cumulative percentage of variance was 78%. And then they used the scree plot. The scree plot is not shown here. So then they decided on 5 year. They call it components because they used another mathematical technique, but this is actually the factors or the constructs. So then if you look at innovation capabilities, there's the factor loadings I was talking about. Now, usually in literature, or in the articles, what they usually do is they present this, say everything below 0.3 is not presented. So there's little bits and pieces in here that you don't see, but it's below 3, for instance. Usually they indicate, I don't think they indicated it here. Usually they indicate what they use as the cutoff, say 0.3. That's just making it easier for you to interpret this. So in this case, you can see our top management provides facilitation in innovation. This one loads with the first component. Then our higher level management accepts a trial and error approach to the implementation of innovation. You see it loads there. You can see this one here also loads there. So all of these items or statements loads onto the first component or the first factor or the first construct. And it doesn't load anywhere else. Say for instance, there was a 0.4 here. Then it would be a cross-loading. So then usually the best is you just throw it out, or if it's much higher here and it makes total sense to put it here, you put it here. And then you just explain that as limitation. So now what you do is you read through these questions here and come up with a common theme. So if you look at all these questions, what's the common theme here? And what you'll see is they come up with leadership here. So they say top level management provides facilitation and innovation, that's leadership. Higher level management accepts trial and error. So that's the leadership part of innovation. Okay. Then you go on with all the other components. The second one here. And the third, yes.
In other words, those questions answer will give us a cumulative contribution to one particular construct that you want to establish. For example, maybe question, maybe you can scroll down a little bit, where you measure the two and then you measure about 4 different questions and then you got there. I don't know if you can scroll down a little bit.
Okay.
Down.
Okay.
This one. For example, this one, the people management as maybe one of the contributing factors. So the 0.949, what is it? Was it a cumulative or a mean of the C21, 22?
Okay. Okay. That's the Cronbach alpha. So that's the second step. So if you first decided on this is now valid and you can interpret it, then you do a Cronbach alpha coefficient and you test these questions to see if it measures leadership. So the Cronbach alpha is a measure of internal consistency. So it measures if all these questions here is consistently measuring leadership. That's the second step, the reliability of the construct. And in this case, it's 0.994. So then it's a high Cronbach alpha. It's reliable. So the Cronbach alpha must be above 0.6 for exploratory research to be acceptable. Above 0.8 is good. And then there's another school of thought that take 0.7 as a cutoff. So this will tell you that this questions here is reliably testing leadership. So your validation is from this loadings here, and your reliability is from the Cronbach alpha here. But you do a Cronbach alpha for each and every one of these constructs here.
All right. Yeah.
So is that fine?
Yeah, it's fine.
So say for instance, you want to measure public innovation, innovation capabilities, like in this case. And you got this article, say you're busy with a master's, and you want valid constructs for innovation capabilities. Then you got this 5 year, you got it from this loadings. So in your questionnaire, you must use exactly this questions here. this question here is out, but this one, this one, this one, this one, and this one is all measuring leadership. And you know it's reliable. So then you can just refer to this article for the validation. So there's the validation done with the loadings, and then the reliability is done here. But the reliability you will test yourself later again. So in your own, even if it's already a valid scale, you'll test the reliability again before you go on with your analysis. You're fine with that? Okay, so that's reliability and validity of the scales. So you're fine with the scales in the questionnaire must be valid and reliable. It's very important because this scales here, or the constructs in the scales, is directly referring to your theory and to the research questions. Okay. Fine with that?
Yeah.
Okay. Let me just... Okay, then the types of questions in the questionnaire. You'll get different types of questionnaire, variables that will influence the statistical analysis. We'll look at that later. Then the statistical analysis techniques depend on the type of question that you ask. And then sample size is also important. We'll talk about that later. Now, let me just recap. So the validation, we looked at the validated scale here when we looked at the article already. So the best thing to do would be to have a validated scale already and just use it. But remember, you cannot mix it up. So you cannot take one article where, say, this innovation capability was validated and mix it up with another one. You take that whole all the questions as is. You're fine with that? Let me just show you that article again, because this is very important and students make this mistake. Say, for instance, you have another article on innovation capabilities and you didn't get everything that you want, because in your theory you have leadership, you have people management, strategy, rewards, and resources, but you have something else there on innovation and you got it from another article. What you'll do is, say the other article also have leadership, but something else that you need. You don't mix these questions here for the two articles. So you keep this set of questions exactly as it is with leadership. So if you want to use this as a validated scale, you must use each and every of these statements with leadership. Then you can, from another article, you can use a construct on its own with its questions. But you cannot mix the questions from different constructs. You're fine with this?
So,
Question on
can you
this?
go slides again?
This is very important.
Are you going back to the
Okay.
slides?
Yeah, let me. You're fine with that?
Yes.
Yeah.
Okay. So take it as a set. Don't mess around with the questions in this set. Okay, if it was validated. Okay. So if you do the validation on your own, you use exploratory factor analysis. That's the article I showed you. You need a lot of data for exploratory factor analysis. So the rule of thumb would be that you take the number of Likert scale statements, in this case 29, multiply by 5. So that's about 150 respondents that you need to do the validity if you do it yourself. And you must remember the risk is if you use it, if you validate it on your own and it doesn't work out, then you're stuck. You cannot do anything further. Then the reliability is the item analysis with the Cronbach alpha. You do it for each and every of the constructs. And then you can use a pilot questionnaire. So say, for instance, you don't have validated constructs and you're not sure about it and you want to do the validation yourself. When you do the pilot, test the reliability of the intended constructs already with a Cronbach alpha, because for the Cronbach alpha, you don't need much data. You fine with that? You can also use the pilot for content to look at the validity of the content of the questions. Okay, now questions on that. Can we go on?
But then,
yes.
There are other approaches that we can use. I don't know how it fits here. Like when you are using the SEM, when you're using structural equation modeling, and maybe you want to employ that one as part of your research.
Yeah, but the structure equation model, you must have a structure before. So you cannot use that for exploratory to validate the factors, because you must know what it will be to put it in the structure equation model.
Yes, but when you are using that one too, I know I wanted to employ that one in my research.
Structure equation modeling.
Yes, I don't know how it fits in our IS domain. I started reading, I started attending reading. So
yeah,
from my questionnaire, I started to design it towards 7.
Yes,
so,
we will look at the structure equation model a little bit, but you cannot use that for validation. So say, for instance, if you use a structure equation model, usually you then have a validated questionnaire already. So then you put down your structure and you analyze it, but you cannot do the other approach would be to do the validation first, and after that's done, then you build your structure equation model from there.
Okay.
But then the best way would rather be to do the exploratory first as one study, and then another study on the structure equation model on another population, because the structure equation model is more like confirmatory. You fine with that?
Sure.
Okay. You must tell us when you want to have a break, or we just go on. You can tell me.
Would you guys like to have a break? Oh, there's a question. Yes?
Okay, yes.
I can see we have 4 different scenarios, and the best is to look at valid and reliable conditions. And then validity of explain the use of exploratory factor analysis. But what about the reliability? How do you identify or know that this is reliable?
Okay, so the question is, you've explained, you can see that there's the 2 issues of reliability and validity. He understands validity, but is it reliability that how do you ensure reliability? Validity, he says he understands, but reliability?
Okay. Okay, let me just, so the validity now, you know what is the factors or the constructs. You also know what is the relating Likert scale items. So for reliability now, you want to see, but is this questions reliably testing the construct? So each and every, say there was 5 Likert scale statements for leadership. All of them must reliably test that leadership. So the Cronbach alpha will give you a figure to show if it's reliable or not, the construct. So you do it for each and every construct. So let me just go to the article again.
What range is that?
Sorry?
The center, I believe, has to do with the expected value, right?
Yeah, the center.
The center.
He talks to the 4 bullseyes. He says, what is the center about?
Oh, okay. Let me just go back to that.
So what I see is, if the thing is reliable, It measures what it measures what you wanted to measure, but you can measure the wrong thing.
Yes.
But validity means you measure correctly, but you also measure the right thing.
Yeah.
Am I right?
Yes, yes. So if you look at the reliability, this is reliable because you're in the same area. So if you look at measurement, all of this is in the same place. So it's reliable, but it's not valid because it's out of the bull. The area is wrong. So you're not measure what you're supposed to measure, but you do it reliably. In this case, low, okay, they don't show validity here. Okay, in this case, it's reliable and valid because you must go for the bull here. But you must first establish validity before reliability, because you must first measure what you're supposed to measure, and then it must be reliable. So you must first go for the bull and then be reliable, like that one. Yes?
Accuracy and precision.
Accuracy and precision.
Yes. I
Yes.
wanted to know, is there any guideline for the middle point? The middle, I believe that it is what we expect. So when you're able to hit the middle there, so I'm sure that there will be criteria guiding us as to what the middle point should be.
So I'm assuming you will still talk about criteria for making sure that it's both reliable and valid.
Right.
I mean, you've already spoken a lot about how to do it, but will you later on touch on criteria for making sure that it beats the bull?
Okay, so validity is actually that factor loadings. That's what's giving you the what do you call it? The proof that it's valid.
Yeah.
Now, to make sure yourself, say if you want to do the validity yourself, say you want to test it yourself, you don't have an article that shows you valid constructs. Then you can first do content validity, you look at the questions, and then you do your literature study, and from the literature study you get, say, your valid constructs, and then you can do a pilot, but you cannot test with a pilot. You don't have enough data to do the exploratory factor analysis. So that this pilot here will just help you. So if the construct is not valid, it will show unreliable also. But the proof of validity is that factor loadings we talked about. That's the proof. You need that. That factor loadings I showed you. That's the proof of validity. Does it answer your question?
Yes.
And then for reliability, the proof of reliability is with the Cronbach alpha, it must be above 0.6 to be acceptable and above 0.8 to be good. There's other measures of reliability also that I use now more something like composite reliability also. Okay. You fine with that?
Yes.
So the factor loadings here, and then the Cronbach alpha with the reliability. Yes.
There's one question, yes?
Yes, also on the pilot measurement, what percentage of the sample size you are taking that you need to use for the pilot measurement?
Okay, so the question is, what percentage of the total population do you need to use to pilot the questionnaire? Or how many people how many pilot?
Okay, we'll look at sample size later, but for a pilot, it doesn't matter about no percentage, because the pilot is just used to sort of make your questionnaire better, and you can test the reliability of that. So with a pilot, if you have 50, for instance, you have enough to test the reliability. And that will help a lot, because then you can test the reliability of the constructs before you do the main study. You'll not be able to do validity. If it's possible, the best way to go about would be to do validity with one study, and then the next study is just using it. But that's usually people don't do that. So if you go for a pilot with 50 people, that's fine. As long as it's not part of the population that you're targeting. It must just be population that has the same characteristics. You fine with that?
Yeah.
When we get to sample size, then we'll look at the percentage of response rate and things like that. Okay. Can we go on?
Yeah, let's go on.
Okay, so the main thing here is the best would be to get an already validated scale like I showed from the article. If not, you do exploratory factor analysis, but you can only do it afterwards, after you got back your data, testing the validity. And then the factor loadings will be the proof of validity here. And then reliability, you do item analysis with the Cronbach alpha. It must be above 0.6. Okay. Okay, we talked about constructs. You find what is a construct. The construct is measured by Likert scale statements. It's actually a latent factor. We cannot measure the factor directly, so we use Likert scale statements to measure it. So if you look at the previous example, leadership is measured by that five Likert scale statements. Okay, fine with that?
Yes.
Okay, we talked about exploratory factor analysis. The constructs must be valid. Looked at that. This is just another example. So if you look at this example here, it's about sustainable transport, or they look at factors of transport. So the first factor would be sustainable transport benefits, then you get traffic problem awareness, then you get cycling safety concerns, and then you get public negative emotion of the public. That's all about public transport. So if you look at the valid constructs, there's 4 of them here. And then there's the factor loadings of the first construct. And this first one points to awareness, sustainable benefits of awareness. Then the second one, the third one, the fourth one. So this is actually the proof of the validity. And then there's the percentage of variance that I talked about. So 26% of the variance is for the first factor. I don't want to go into this now to confuse you, or I can explain it if you want to. Percentage of variance. We talked about that. That's just a criteria for deciding on the number of factors. You're fine with that. It must be 60%. I don't want to go into too much detail. Anybody have a question on that?
No question.
Okay, then you have the Cronbach's alpha here. You can see this 2 is not reliable here. This one and that one. So they cannot use this 2. Now, what is the point of this whole reliability here and the validity? In the end, we want to have a score to do the analysis with. So we want to take these questions here and take the average of the responses of the respondents and make a score. And we want to make a score here. Or the previous example, we want to have a leadership score. And we cannot do that if it's not reliable. So if there's a question here that's unreliable, we must throw it out before we calculate the score. So in this case, we cannot calculate the score for any of these 2. So this person here can only talk about the first and the second factor. That's it. And report this 2 as unreliable.
Because it's not enough.
Yes. Sorry?
0.57 and then the 0.59, the Cronbach alpha value is less than, which is 0.6.
Oh, okay. Yes. Don't get confused. This is the factor loadings for the validity this year. What they did is this is sort of confusing because they put it all in one table. This Cronbach alpha here is the Cronbach alpha. It's not the loadings. This one is the loadings. So the loadings must be above 0.4, these ones.
Oh, right.
Yes, yes. That's the loadings. So that gives us the validity. So this question resides there. And then the Cronbach alpha is in here. It's just confusing the way they're reporting it.
That's fine.
Okay, and then, yes.
Yeah, I've got one.
Sorry?
Okay, now what I wanted to say is just before the question, you said that the last two cannot be used because of the number of items. You need more than 3.
Yes. Yeah, you need 3 or more. So even in a structured equation model, the minimum is 3. So that's why, say for instance, you develop your own questionnaire. You go for between 4 and 6 statements per construct. Because if you have 4 and you lose 1, you're left with 3. But if you have 3 and you lose 1, then you cannot calculate a score and you cannot use that construct. Because 3 is the minimum number of statements. And then the Cronbach alpha is also not even reliable here.
Constructs for the factors, right?
I think you're talking about the constructs for the factors.
I'm talking about the number of items per construct.
So like, for example, cycling is a safe transport option. There's 3.
Yes.
You need more to really make a conclusion.
3 is enough. That's the bare minimum. But this 3, the Cronbach alpha for this 3 is 0.46. So we cannot use this 3. But 3 is the bare minimum. But say for instance, you do your own and you have this 3 here and 1 is unreliable and you need to throw it out to try to improve the Cronbach alpha, then you're stuck because you don't have enough to work with. So if you had 4 and you could throw out the unreliable items, it could have worked out maybe.
Actually, this is new to me. That is not my area. So I'm trying to understand where we have the group is. For example, the last one, which is 3. I think different constructs, 3 different constructs for a factor.
So those will be items. A car is essential to my needs. It's an item that you find on the questionnaire.
Yes,
and that item,
groups.
yes, and those 3 items are related to one of the constructs from the theory. Am I right?
Yeah.
Sure. Yeah.
Oh, okay.
Yeah.
So that questions will be one.
Yes, and those things are the factor loading cells.
Yes. This is the factor loadings here. Oh, sorry.
So like in your theory, you will have, let's say, five constructs. But for each of them in the questionnaire, you will need to have at least 3 or 4 reliable items that you ask about.
Yes.
Maybe you can show the matrix. Maybe you can show the matrix at this point.
Yeah, maybe let me just, if I can go into the statistical package, it will maybe make more sense for you because then I can show you a
But don't you have the matrix on the slides where you link the research questions?
Oh, the research matrix. Oh, okay. I thought you want to see the factor analysis.
Yeah, no,
I think you're fine with this factor analysis, all of you.
Yeah, I think the principle is fine for now.
Okay, so we talked about validity, reliability, then we want to calculate scores. Then, yeah, we'll get to the research consistency matrix. Types of questions, you fine with that?
Yeah,
Let me just go through quickly. Yes. Yeah. Because the matrix, I will go to the matrix after we've done the statistical analysis. Otherwise, they will not be able to fill it in. Okay, so you all fine with the validity and reliability?
Yeah.
Okay. If you look at types of questions in your questionnaire, if you have categorical questions, which is nominal and ordinal, you just have categories. So you can look at percentages and frequencies when you do analysis. So you don't have much options there. But if you have a continuous variable, that's like, say, for instance, your construct score. So that's the average of the Likert scale statements in the construct. Then you can do much more with it. Because with a continuous variable, you can look at mean, standard deviations, all of that. Okay, you fine with that? So your constructs scores that you calculate will be continuous. It will not be ordinal anymore. Yes. Did somebody ask something? Okay. Okay, the Likert scale statements, just to quickly on that, how large must the scale be? The larger the scale, the better statistically, because you have more information. So a 7-point scale is better, but people must be able to understand it. So that's why a 5-point scale is used a lot, because people are comfortable with it and they know what to answer. If it's a 7-point scale, maybe people will not know the answer between slightly agree and agree. Okay? Then the neutral and the don't know. Please don't put in a don't know in your Likert scale items, because what will happen is the don't know cannot be part of the analysis, so all of that will be thrown out anyway. Okay?
They
Yes.
say
Neutral.
neutral.
Yes.
How do you interpret that? More or less, the person don't know. He's sitting between them. So,
Yeah.
okay,
but
neither.
yeah, but remember, you don't want to ask people their opinion about something they don't know nothing about. So if you want to explore if people know something about it, then you will not use scales like this maybe. Then you'll approach it in another manner. Because people must have some sort of opinion on the statements you provide to them. That's very important, because if they're not able to answer this, then it will mess up the whole questionnaire.
Yeah, then you've got the wrong empirical situation.
Then the neutral in the middle sort of gives them an escape clause if they don't want to give an opinion. That's why sometimes people take out the neutral and then have a 6-point or a 4-point scale. But then there's ethics surrounding it, so it's difficult
So
to say.
with a 6 and a 4, it means that there's no middle ground. So you have to you want to force them in a direction.
Yeah.
So then it's an ethical thing, or you need to validate in your ethical clearance why do you want to force a person in a positive or a negative. You don't allow them to take a neutral ground.
Yeah.
You know, that's the more reason why we usually take most of the questions, especially on the Likert scale, with odd numbers. I don't know how.
Yeah, the odd numbers.
Because at least with that one, either you are skewed towards this or that. So I don't know if there is a rationale, because like if you choose a 5-scale Likert, then you know that you can't sit in between. You can't be 3. You can't be, 6. At least you should be at brother son.
Yeah, and that depends on the purpose of your research. Do you want the person to make a choice? Yeah. Or will you allow him to take a neutral position on the issue?
Yeah.
So it depends on the research question at the end of the day.
Yeah.
A typical example, when you are having the 5-scale like 5, strongly disagree, 4, disagree, 3, like neither, neutral. Then you have 2, like agree, 1, strongly agree. You see, so if you are having majority of your respondents saying neutral, so what are you doing? You cannot make strong arguments there. So how do you discuss that?
But it depends on what you want to do. So your research question will determine. But we can talk about that more.
That's risk. Yeah, that's risky. If everybody say if it's sensitive issues, they can maybe all answer neutral. But okay, that's another issue. Okay, you fine with that? If you do the analysis, then you're stuck. You're sort of stuck because you have a sort of a constant to work with. So you will be able to report they're very sensitive, and that's it. Okay, you're fine with this?
Yes.
Okay. Now let us get to the statistical analysis techniques. If you look at categorical data, so say male and female, you calculate percentages and frequencies. And the charts that you can use is pie charts and bar charts. So a pie chart, usually just 2 or 3 categories, not more. Otherwise, you use a bar chart. And then if you look at continuous data, that's your construct scores. You can calculate means, standard deviations. And then the graphs that you use is a histogram and a box plot. You're fine with that? Okay, statistical. Okay, let us look at the relationships now. So say, for instance, you want to look at 2 categorical variables, compare 2 different categorical variables. Say, for instance, you look at males and females, which is categorical, and some sort of a yes-no question. Then you look at the relationship between the 2. Or say male and female and the age categories. So then you use a table or a clustered bar chart for your graphical presentation, and then the Pearson chi-square test to test the association between these 2 variables. Pearson chi-square test. Okay, you fine with that? This is just quickly to go through which techniques you use when, because this whole workshop is still part of the design. Then if you have a continuous variable, say for instance a construct score here, and you have a categorical variable, the graph that you use is a box plot, and the analysis that you use is analysis of variance. Say for instance you want to look at this leadership construct we talked about, and you want to compare it for the age groups. Is there differences between the age groups in this leadership construct? Then you use analysis of variance. If it's 2 groups, you use an independent t-test. But the analysis of variance, the f-test from the analysis of variance will give you the same answer as a t-test. Okay? You fine with that? Then the relationship between 2 continuous variables. So say for instance, you want to see leadership on the one hand, and you want to look at performance. So leadership is your one construct, consisting of 5 Likert scale questions, the average of that. And then say performance. Then you use a scatter plot to graphically present it. And you must look at the relationship, because if it's not linear, then you can not use this analysis. You can use a Pearson correlation analysis to see the relationship between the 2, if there is a relationship or not, and what is the strength of this relationship. And for that, you use the correlation coefficient. So the correlation coefficient will show you the strength of that relationship and if it's positive or negative. Fine with that?
So, Bob, my whole worry is that this PhD, I've sat in several PhD, most of these external examiners and those examiners at the PhD,
yes.
you start to do this, they tell you this is a master's research.
Yeah.
This is a master's, maybe they start to draw regression, correlation, t-test,
yes.
and simple maybe correlation analysis.
Yeah.
Tell me it's a master's work. They don't see doctrines or whatever you are doing.
Yeah.
And what are you cannot infer further implications of those findings on research.
Yeah, but
for example, that's why they want to see how this research affects the effect of this on that. That is why most of us started to read about this SEM, whatever, just that to make the analysis look a little bit PhD.
Yeah, but remember, we'll get to that. You must build up to get somewhere. So even the correlations that I talked about, you must understand that first before you go into that. So if you do exploratory analysis, for instance, you even do the scatter plots and the correlations even before you go to STEM or regression or any of that techniques. So this is just building steps going forward.
All right. Sure.
Okay, we'll get to that. Say, for instance, if you look at this one here, analysis of variance is a modeling technique also. So you can have one continuous variable here, say, for instance, leadership, and then you can have a lot of categorical variables here. So say, for instance, you look at leadership and then you bring in gender and age group and a lot of biographical information here. And then you have a model. So then it's not one-way analysis of variance, then it's two-way or three-way or four-way or five-way. So this can give you a model already. You fine with that?
Yeah.
Okay, and this could be used for the descriptive design, for instance, if you want to explore the demographics. Okay. Okay.
Yeah.
Then with the correlation, you always start with the correlations to understand your data, and then you go further. So say, for instance, you have a model, you take your dependent variable and all your independents, and you look at the correlations first to get an idea what's going on, and then you go further. Okay, then, sorry, why did it jump now? Okay, regression. When you, in your research question, if you talk about the influence and you want to see the influence of some variables on another variable, then you can do multiple linear regression, for instance. So you can look at the influence of a lot of variables. It can be continuous and categorical on one dependent variable which is continuous. What is important for your measurement, this dependent variable here, you must measure thoroughly. If you cannot measure this variable here thoroughly, then you're stuck in your research. So if this is not valid or reliable, this measurement here, say for instance, you look at leadership and everything that influences that, then you're stuck. So make sure your dependent variable in your research is measured thoroughly. Okay, you fine with that?
Question on that.
Then, yes.
Does it mean that this one will not apply to latent variables?
Does this mean it does not apply to latent variables?
Okay, yes.
The multiple linear regression. We use it when variables can be measured. That's how I got it.
Is it right?
Sorry? The latent, you're talking about the structure equation model now. What are you talking about?
I'm talking about when to apply the multiple linear regression.
When to apply the multiple linear regression?
Okay. Okay, say for instance, yeah.
Are you saying that the multiple linear regression can be used when and only when the variables can be measured? Unlike the latent variables we have seen earlier on.
Yes, yes. So it must be valid and reliable. Let me just, can I just draw here quickly? Sorry, it's, can you see? Let me just share again. Okay. Okay, can you see?
Yes. Yeah.
Okay, let me talk about the example. Say for instance you have performance here. You have performance. This consists of 5 Likert scale questions. Okay, you fine with that?
Likert scale question.
Yeah, this is all Likert scale questions. We know that performance is valid and reliable. So we'll calculate the score here. So we'll take, say this was 5 questions, 1, 2, 3, 4, 5. And say I'm answering this. This is strongly disagree, disagree, neutral, agree, strongly agree. I'm answering this now and I feel the performance is very good, agree, like that. Then I add this here, the 1, plus 2, plus, that's a 1, sorry, this is a 5, it's 1 to 5, sorry. So it's a 5 plus 4 plus 5 plus 4 plus 4. So that's 16 plus, so it's 26 divided, is that correct? No, it's 12, 22 divided by 5, so it's 4.2 on 5 is 0.4 or something. I cannot work out so quickly. So this is the score that I got. This score here is what you use in your regression. So performance will become a new variable. That's what you use in your regression. So that's now the latent construct. In a structural equation model, you put in everything. You put in Likert scale questions also. In a regression, you put in this score that you use here, this performance score. So if this is not valid and reliable, you cannot have a measurement for performance for your regression. Even in your structural equation model, it will also not work out. The structural equation model just use the Likert scale questions together with that. Yes?
Yeah, I think you answered the question. Sure.
Okay, you fine with that?
Yes. Yeah.
Okay. And then, yeah.
Now he wants to take a picture.
Oh, okay.
Yes, I'll be back.
But the recording will be available, eh?
Oh,
Yes, I hope it doesn't bomb out or something. But hopefully, yes, I'm recording everything. Okay, you fine with that?
Yeah. Yes.
Okay, let me just go back to. Okay, just one thing here, categorical variables in a regression. If you use categorical variables, for instance, say your one categorical variable is age group, and there's 4 different age groups, it will mean that you'll have 3 dummy variables in your regression for the 4 age groups. So you must keep that in mind when you do regression. Keep that in mind. So this categories here will make you need more data. So if you have a lot of categories and you have a lot of variables in your regression, you need a lot of data. Okay, you fine with that? Okay. Okay, let us just look at the framework. So say, for instance, you want to model a framework now. So it's not like a regression, just independent variables influencing a dependent variable. So now you want to fit this whole model, this whole structure. Then you use structure equation modeling. So that's sort of a mix between exploratory factor analysis and regression, if you can think about it like that. So what will happen is you'll use the Likert scale questions in this model here. Not like what we explained earlier, that you calculate the score from the Likert scale questions and create a variable. That is all part of the model. But you must know what this model will be. So you cannot validate. So you must have validated constructs before you want to do something like this. Because you want to know what is the structure, and this structure is informed by theory. Okay? Fine with that?
Yeah.
Let me just see. Okay, then with structure equation modeling, you get the measurement part of the structure equation model. That's sort of looking at the validity of the constructs, but you must know what is the structure. And then the structural part here is where you look at the relationships, different relationships in this model. So let me just show you an example. This here, this is acceptance, perceived ease of use, perceived usefulness, and skills. So this is a deviation from the technology acceptance model. So these people want to see if skills, ease of use, and usefulness influence acceptance. This measurement part is just this part to see if this is all measuring correctly. So this must be valid. And then you get your structural part, which is the hypothesis or the relationships that you want to test. So you see, this is the first hypothesis you want to see, skills. Oh, sorry. Skills influencing perceived ease of use, perceived usefulness influencing acceptance. So this whole thing is the structure equation model. So you can fit this whole model and then see how well did the model fit. Okay. Any questions?
It kind of comes together now.
Okay.
There's a question.
Yes.
The hypothesis ranking that I saw somebody's work and I realized that those hypotheses are backed by theories and people's work. So kind of cited. And you still have to validate it, even though people might have done certain works already, and you are using their hypothesis.
Okay, so question, I don't know if you got that, but hypothesis is actually something that comes from theory. You have a theory, but you develop an hypothesis. Question is, do you still need to validate these hypotheses if it comes from somebody else?
Okay, hypothesis, statistically, you want to test the hypothesis. So, there's no sense in testing a hypothesis that was already tested by somebody else. Unless you test it on a new population, or say, for instance, in this case, this year is already standard. So the people bring in this part in the model, but they still test this year to see how it changes, because maybe some of this can change according to this. Okay.
So to just re-emphasize, let's say you get the theory from somebody else, and that person tested hypothesis 1, 2, 3, 4, and proved them all, there's a positive relationship. So now you test the same hypotheses, but in a different population, let's say in Ghana or wherever, and you come up and you realize, but maybe hypothesis 1, 2, and 3 is positive, but 4 you can't confirm. And it might then be that you come up with different results. Is this correct?
Yeah. So it's in a different context. Okay. And this is how the full model is looking. So you'll see there's the questions. This is the bare minimum, only 3. And that's the Likert scale statements, that's the latent construct, and there's all the relationships that we test, and that's the full model. Okay? Then, if you do confirmatory factor analysis, we didn't talk about that. That's the second step after exploratory factor analysis. So that could be done, say for instance, you did exploratory factor analysis as a first step and determine your constructs. Usually what people do is they mix the two and put it, or you just use exploratory factor analysis as your validation and you stop there usually, because people don't have the luxury to do 2 studies, say for instance for a PhD. But the ideal would be to then, as a second step, say after you've done an exploratory factor analysis yourself, do a confirmatory factor analysis, and this here would be a confirmatory factor analysis. So this is confirming this 4 constructs, but you'll see there's a structure here. So the exploratory, that's why the exploratory is the first step, because you want to explore what is the factors, and that's the first step in the validation. The second step is confirmatory when you have this structure. But usually, like I said, people just stop after the exploratory factor analysis because you don't have the luxury of 2 studies.
So that answers your question of how to make a PhD or doctoral.
Sure.
You see.
This is what the professors want.
That's what they want.
Yeah, so all the time they just want you to make confirmatory analysis. How does this relate to that? What effect does this? How does this one support this one?
Yeah.
Does it exist any? Then you ask all those.
Yeah. So it comes to the theoretical and methodological contributions.
Yeah.
And the level of depth of argumentation.
Yeah. That's where rigor also comes in.
Rigor,
Yeah, so say for instance, if you want to do it very properly, you will do, this is the 4 constructs here, this year, this is the one you bring in. So you do exploratory factor analysis with the first study, using this 4 in the factor analysis to see, exploratory factor analysis, to see maybe it changes or do you get out of 4. Then you do, that's a proper full study. And then the second study, you can do confirmatory factor analysis on this now. If it was confirmed with the, if you got this out of the exploratory and you confirm it now again with another study. And then you can, but people sometimes just skip this confirmatory factor analysis and just jump straight into the structure equation model. Because the confirmatory is sort of part of this. So you can do exploratory factor analysis, the first study, and then the same as the second one, for instance. If you want to do it properly.
Yeah, so I mean, you know, the difference for me between a master's and a PhD is like a master's will simply use the model, follow all the methodological steps rigorously, and just confirm.
Yes.
But with a PhD, you need to go further and say, let's elaborate on what this means for the theory that we started off with.
Yeah.
Can I improve the theory? Can I adapt? Can I contextualize? How do I particularize? It's called theoretical elaboration.
Yeah. Yeah, and if you don't have the luxury to do 2 studies, which most people don't have, then what you'll do is, if you do the, say, the exploratory factor analysis here, and you got out the same 4, because it could change, but say you got out the same 4, then you just use it and plug it into the structure and test it. So you use the same population to do both. That's what most people do because they don't have the luxury to do 2 studies. But yeah. That's not the ideal, but that's how it works because we don't have the logistics to do 2 studies usually.
It's also the issue of, you know, a PhD student can never say, I didn't have time to do more. The examiner will just say, you know, this is a PhD, you must make time. You know?
Yeah.
So do it properly, my advice.
Yeah, if you could do the 2 studies and then you can do 2 articles from it also.
Publish from it,
yeah. But if not, then you'll still just do on the one population. You do the model also. But the most important part is to make sure of the validity, because everything falls down if that's not in place, validity and reliability. Okay.
The other thing that I've also seen with quantitative research where it falls through is the guy says, I've used snowball sampling or convenience sampling, as opposed to real, what is it? What do you call the real sampling?
Random sampling. Yeah.
Random representative sampling.
Yeah.
So snowball sampling, you know, it's going to say, you know, the sampling sample is subjective. But then when you have a real representative sample, you know, then the results become meaningful.
Yeah. Yes, we'll look at sampling a little bit. You want to take a break or we just go on?
You need a break? Yes?
Yeah, let's finish it.
Okay. Finish.
Okay, the validity and liability sample size, we looked at this already. You have it in your slides, I think. You have the slides?
Yes, I emailed you.
Okay, so the rules of thumb, sample size for validity, all the statements all the statements that's part of the validity, say for instance, if it's public, the innovation capability we looked at earlier, so it's 29 statements, multiply by 5, so that's about 150. Reliability need much less because you take the number of statements per construct. So usually there's 5 per construct, so that's about 50. So you don't need much for reliability. And let us look at a research consistency matrix. This is very important. Okay, you have your literature review or your theory. So you start with your theory. Then you'll have your hypothesis, propositions, research questions. So in the first line, you put in your first research question. This is very simple questions here, but just to give you an idea. So say, for instance, you say here, you want to investigate the relationship between gender and type of customer. This is a very simple example. So then in the research instrument, in your questionnaire, gender is asked by question C1 and type of customer by question C5. Now, it's very important to be specific here because people forget things. It just happens in life. So say, for instance, gender, you did a gender study and you don't ask gender in the questionnaire, then everything is gone if you want to compare the two, say, male and female. So this is to be specific to make sure everything in this research question is measured. So we measure gender there, we measure type of customers with that question. Then what is the type of variable? We talked about nominal, ordinal, and continuous. So gender is nominal, and then type of customer is nominal. So then we know we do a Pearson correlation analysis. Then the next one, compare differences in price preference for the type of customers. Price is this statement here. What I would do is put in another column here and see if it's valid and reliable, because price here must be valid and reliable. And then type of customer is just a nominal or categorical variable. So then the construct score is continuous, and then customer type is nominal. So for that, we do analysis of variance. And then the third one, investigate the relationship between price and advertising. You have price, you have advertising. Both must be, is construct that must be reliable and valid. It's both continuous. So we do a Pearson correlation analysis. Together with this, if you have a framework or a model, like I showed you with the structure equation model, you'll have your model presented together with this, and then you have hypothesis from that model, and it must all align. The model, this research consistency matrix, the questions in the questionnaire, and your analysis. This is very important to get everything in line.
And it's also very useful, this instrument, to persuade your examiner that you've got constructive alignment between all the different aspects of the thesis.
Yes.
So a qualitative version of this would be, you've got your research questions, you've got the key themes from literature, you've got your interview questions, which will then be the open-ended or qualitative interview, and the fourth column will be the purpose of the question, where you link it like explicitly to the research questions. But the same principle follows.
Yes, yes. This can be used for qualitative and quantitative, yes.
Okay, so can you repeat this in your findings and then bring the same metrics there when you indicate one findings?
Yes.
They can give some rating whether your finding was conforming to statistical significance or not there.
Yes. Yeah, definitely. The last chapter, you have to revisit these types of things where you show how the findings answer the questions and how it links to what you've done, what you said you're going to do.
Yes, yes, yes. And then when people come and see me, I ask them to fill this in before they distribute the questionnaire, because you must be able to make sure you can do all of this. Otherwise, in the end, we want to ensure we can do the statistical analysis. Otherwise, you're stuck. You cannot answer your research question or test hypothesis. Okay. You fine with this?
Yes, sure.
Okay. Okay, sampling. We'll look at it very, very, very quickly. Like, very quick. Just the main issues. We look at general principles, type of sampling techniques, and then sample size. Now, just the general principle. We have a population. We want to have knowledge about this population. So we use a sample. We save cost. Just remember in these days now, say for instance, if your population is available on internet, say your population is a certain company, and you will be able to send it to everybody. Then you say, send it to everybody. Don't take a sample. Don't then take a sample. So if it's viable to send it to everybody, rather do that. Okay. Now, what must be in place to generalize, because we want to generalize from the sample to the population. Now, just be one thing on the population. You must be very clear on your population. So you must be able to say your population is, say, this is the age group, it's in this province, or you must be very specific about your population, because you need a list of the population in order to generalize. Now, this is not always possible, so we'll talk about that. But if you have a list of this population, then you must randomly draw people for the sample. Now, that must be done to get, everybody must get the same chance to participate. Otherwise, there's biasness in it, because you can then just give it to people you want, you know, has a certain view. So it must be randomly drawn, and then it must be representative. That's the next thing. So say, for instance, if your population that you look at is more, say, younger people between 20 and 30, say 80% of your population is between 20 and 30 years old, then your sample must also be 20 to, say 80% must be between 20 and 30. So the sample must be representative of the population. So for representativeness, you make sure the characteristics that's important, and you get that from literature sometimes, say if age has an influence on their view, then it must be representative according to age. But you can decide on that. Right? So to generalize, it must be randomly drawn, and it must be representative, and you must have a list of the population. Then the response rate, if you look at the response rate, the response rate has an effect. So say if you send it out on email, the response rate is between 2 and 5%. So you must take that into account. So if your sample is, say, 300 people, but you have a 2 to 5% response rate, then you'll get back 30, which is not enough to do anything with. So you must take that into account, your response rate, not only the sample. Then you get probability and non-probability sampling. For probability sampling, you'll be able to generalize. If it's non-probability sampling, you cannot say you generalize. So then they'll just mark you down and say you don't know how to do research. So if it was a non-probability sampling technique, you just state clearly that you will not generalize. Okay? That's very important. Probability sampling techniques, you get simple random sampling, systematic sampling, stratified sampling. Now I'll just look at stratified sampling. So stratified sampling means you stratify according to certain characteristics. So say, for instance, the age groups I talked about. So you'll know in the population what is the age group. So then with the age group, you make sure you get, say, enough, or the proportion of young people that you draw for the sample is the same in the sample as in the population. So this technique here, stratified sampling, will help you to get representativeness. So if you go for a probability sampling method, stratified sampling is the way to go, stratified random sampling. Then cluster sampling you can use if you want to have geographical representativeness. Say like in a city, you have north, west, east, and south, and you have different clusters, and you make sure you want to have enough in each of the regions. Okay. And then you get multi-stage sampling. So that's what they use for large studies, or say Statistics South Africa will use it, or in Ghana, the statistics department will use it. So they have different stages. They sample at province level, and then they go down like that. Usually you don't use that in a master's or PhD. Then you get non-probability sampling. So for this method, you cannot generalize. So convenience sampling, for instance, that's the worst way to go about. So say if you're forced to go non-probability sampling, say you don't have a list of the population, then go for quota sampling. Because for quota sampling, you'll get representativeness at least. So even if you cannot generalize, there is representative at least. So say with a quota sampling, what you do is you make sure you have the quotas correct. So what is the quotas? That's the strata. So say for instance, the age categories. So you must make sure you have enough percentage of people in all of the age groups here. So that's the quota. So you keep on sampling till you get that quota. So say for instance, the young people is 80%, between 20 and 30, you make sure you get that quota. Okay. Then snowball sampling, you only use this when you're not, they use it, say for instance, if you want to investigate experts. So experts, you cannot get to all the experts, you don't have a list of them. So one expert refer you to another one. So then it makes sense to do snowball sampling because that's the only way to get to that people. But there's biasness in it clearly. Okay. You
So,
find that? Yes.
If I can comment on snowball sampling. So in quantitative research, which is typically positivistic research, you want to avoid the biases. But let's say in the case of interpretivist research, you want to get a sample of people to interview, but you are very interested in finding like-minded people.
Mm.
So you then use the snowball sampling because then when you do your interview, you ask them and you say, who else has the same sort of view on this matter? Who can you advise me to look at? And that actually then becomes a strength of the approach. But then it aligns well with the interpretivist worldview or the interpretivist philosophy. So all again, it depends on what philosophy you want to follow and which method fits well with it.
Yeah. Yeah.
Question?
About purposive
Purposive? The question is purpose. Is it purposeful? Purpose of sampling.
Purposive sampling is you can they use that for quota sampling also.
Okay, quota sampling.
They use it for quota sampling. So you say you did it this quota, this is what you want to get.
Which one is?
Which one is the judgmental?
Judgmental sampling?
I think that's more used in qualitative.
It's more like snowball.
Yeah, it's more used in qualitative. In quantitative,
Just like judgmental.
So, I mean, for example, in a deeply qualitative environment, when you start doing interviews with people, they give you certain perspectives. So you want to see if you can get other people to help you interpret those perspectives. So either then you find people who's got the opposite view, or people that can like have the same sort of view to help you with this. But then it is just totally like a judgmental or a snowball style. You are very biased, but you want to be biased because you are interested in a particular view.
Yeah. In the quantitative, if you use this, because it's used a lot, because people don't have lists of the population. But then, that's why I said, then go for quota if you can, because at least you have representativeness. And you must be very clear that you cannot generalize. Okay.
But now the interesting thing with so in quantitative research, you can generalize to the population. But in interpretivist research, the way you generalize there is you generalize to theory. So you get a very subjective point of view and you get your discussion of themes and you come up with some sort of theory. Then you generalize to theory. There's different ways to approach.
Yeah, and even in psychology, even if it's quantitative research, they would reason and say, but this phenomena exists for all people. So even if you don't have a random sample, the phenomena will still exist for people, for persons. So there's a bit of a gray area there. You must just be clear with the quantitative that if it's non-probability, you don't generalize and you leave it up to the person. But if it's at least representative then you have something to work with. And then what you'll state is you'll state that the statistics will only hold for the sample. You must state that clearly somewhere in your results section.
There's a question.
It is saying that with the non-probability sampling technique, you can't generalize your findings.
We can't generalize.
But I was thinking it is based on your limitation, say whether you can generalize your findings.
Yes. Okay. So you know, your sampling method has limitations to it. So those limitations must feature in your final chapter where you say, this is what I could do and this is what I could not do. But remember now, for research to be a doctoral research, you can't have just limitations at the end of the day. You say, you know, I couldn't do this, couldn't do that. At some point, you need to say, I'm doing something new and novel, and these are the reasons. You know, if you say I'm using snowball sampling and you say it's a limitation, then the examiner is going to say, what's the relevance of this in the first place? You know? Yeah.
Yeah.
Yeah. Thank you. Yes.
Okay. Is there another question?
No. You can continue.
Okay. The main thing here is just to be clear on what you're doing. Because I know most people don't have a list of whatever they want to measure of the population. So, but then you be clear. You don't try to say you want to generalize if you cannot. Then sample size. This is a very difficult thing. There's a lot of different criteria that you must look at for sample size. You cannot just look at one thing. If you generalize to the population, you have a list of the population, you can use that sample size calculator. So usually at 95% with a 5% margin of error, you get to something like 384 something. Then rules of thumb between 30 and 300. 300 is a good figure in general sense to do a lot of, you can do most statistical techniques, models, everything if you have 300. So that's a good, nice figure to have. Then if you cannot generalize or it doesn't, you look at other issues also. You must be able to validate the questionnaire, for instance, the constructs. So say, for instance, you'll be able to, from the calculator, you got a figure, but you need more data to validate, then you must make sure you must have enough data to do the validation. Okay. Reliability don't take much data, so you don't care about that. Then, okay, there's the sample size calculator you can look at. Just look at that on your own. You must be able to test validity. That's the important part. And then statistical techniques also, and modeling. So for modeling, you need more data. So certain models need more data. If you have more variables in the models, you need more data. Say for regression, you need 10 people per independent variable at minimum, starting with a sample size of 70. So what you'll see here is there's a lot of things you must look at. You cannot just look at the sample size calculator. You must be able to test validity. You must be able to look at, employ all your statistical techniques. So after you've looked at all of that, then you decide on your sample size. And then remember, that's what you get back, not the samples that you take. So if you take a sample of 1,000 and you only have a 50% response rate, then 250 must be enough. So this is very important. So this sample size I'm talking about here is actually what you need for your analysis, not what you send out. You fine with that? Okay. Then techniques that have categories in it, like chi-square tests or any categorical variables, need much more data than continuous variables. So if you say, for instance, if you look at two categorical variables, you draw the table of it and you make sure you have, for all the different combinations, you have enough people to test. Okay. Then gathering data, let me just go very quickly how the data must look when you do your analysis. You can have a matrix, or Excel is set up in a matrix format. So in the columns will be your variables or your questions, and in the rows will be the respondents. in the first row in your Excel sheet, you put in the heading. So say just start with number and then Q1, Q2, Q3. Don't put in long labels there. It will make a mess in the statistical package because you'll look up and down for which variable to use. So let me just show you an example in Excel. So there's a count, or say that usually you put in the number. So if you have paper-based questionnaires, you number them from 1 to wherever. And then you'll be able to go back when you look at errors in your capturing. And then you'll see there's the columns, which is the questions. There's a Likert scale. No, this was 3 biographical questions. And then there's Likert scale questions. Then you'll see from the second row, the first row, that's your heading. You see that A 1.1. So this is the statistical package will pick this up as the name of the variable. And then from the second row, it will start reading the respondent. So that's the first respondent, that's the second respondent. Just keep in mind, if you have questions like this, 1 answer per column. Sometimes people use Excel for statistical analysis and then they split the columns here into all the categories. That's not what you must do. So if you have 1 question there, say this one, and it's a Likert scale question, then you put in the relevant answer here. You don't split it into 5 categories. You only split this here if there's multiple choices. So if a person can fill in more than 1 thing, you have more than 1 column in here. You fine with that? Format of the data? Okay.
In Excel.
Yes. You fine?
Yes.
Okay. You put it in Excel, and then you can import it into a statistical package, and then the statistical package put it in a database that the statistical package can read. So all the statistical packages work in the same manner. So you capture the numbers, 1s and 2s, and then in the statistical package, you'll give it labels, say 1 is male, female is 2. And then the statistical package has procedures that can help you with analysis and graphs and data manipulation. Then if you look at the statistical packages, SAS is the biggest one, Statistical Analysis System. SAS has a very proper programming capability, very strong data manipulation capability. Then you get SAS Jump, which is a subset of SAS. I'm using SAS Jump. SAS Jump have this graphical user interface, so you don't have to program. You can also program, but you don't have to. And it's quick. It's much quicker than SPSS, for instance. Then you get SPSS, statistical packages for the social sciences, but it's not only social sciences. And then SPSS is very user-friendly. You can do everything in there. You cannot do test reliability, for instance, in Excel, for example. Then you get packages like Stata and Statistica. And then an open source package, which is free, is R. But this is a very powerful package, statistical system. SAS and SPSS can import R. And R has a lot of libraries that you can use. So R is really a powerful package, and it's open source, it's free. So 4 times a year they update it. But it's difficult to learn. It's not so easy to learn.
And
You know about R.
Smart PLS.
Smart PLS.
PLS.
Okay.
PLS. Smart PLS. Smart PLS is just used for, it's not structured equation modeling, it's partial, it's not least squares. But it's linked to structured equation modeling. So it's a package specifically for that. Partial least squares regression, I think. But in R, for instance, you can just download a library for PLS and do it. If you want to do structured equation modeling in R, you download the Lavon library. In SPSS, you need an ARMOS version to do structured equation modeling, for instance. Okay. You fine with this? You know about R, where to get R.
You just Google it, isn't it?
Yeah, R is.
Yeah, it's r-project.org. Okay, r-project.org when you want to look at R. Okay, you fine with that?
Yes.
Then, okay, just the steps in the data analysis cycle, then we finished. The data analysis cycle, you use the data analysis cycle to do analysis. So first you'll read in the raw data from Excel into the statistical package. Then you'll create a database in the statistical package. So what it means is you give it the labels, the variable labels and value labels. So the one male and two female, and then the measurement type, like categorical and continuous. You set that all up in the statistical package. Then you do data verification and cleaning. So you look at your descriptive statistics and see if there's any errors and clean that. Then you make sure the research instrument is valid and reliable, the constructs. Then you calculate construct scores for this valid constructs. In SPSS, you use the compute score. So that's new variables, and that's the variables you'll use in your analysis. Then you do descriptive statistics. You start with that, of all your variables, to get an idea what's going on. Then you do exploratory data analysis. So now you explore your data. So you look at the relationships, and you can use all that graphs I talked about. Look at the relationships and explore it. It's very important. Before, say, even if you go to SEM or any regression, because there can be outliers that mess up everything. It will mess up your fit, and you will not pick that up if you don't have graphs. So it's very important to do this exploratory data analysis. And then you'll already see there's patterns, and then you answer your research questions by the data analysis. And then when you answer your research questions, and you do statistical analysis, you do the statistical analysis test, you look at the effect size. You know what is effect size? That's the practical significance. So say, for instance, for a correlation coefficient is the effect size. It gives you the strength of that relationship. Okay? Or in a regression, you look at the beta coefficients. That gives you the strength of that relationship. Okay, so that's the effect size. You have your statistical test, you have your graph, and you have your descriptive statistics. That's what you do when you do a statistical analysis. Maybe you will not report all of that, but that's what you need to do for the statistical analysis. You fine with that? And then you have, yes?
Yeah, no, I wanted to say, at PhD level, you have to have some sort of theoretical elaboration incorporated in the last two steps.
Yeah. When you do your interpretation and conclusions, you go back to literature, and remember, theory drives everything. So here you go back to theory, because you just did your analysis now to see what the people's view are, but this is going back to theory and literature. So the statistician cannot do this for you. You must be interpreted with your theory in mind. Okay. Fine with that?
Yeah.
Then just possible problems, important questions that you can leave out. You pre and post, you don't link the questionnaires, you had wrong coding or overlapping categories. Say, for instance, for age group, you ask a question 20 to 30 and 30 to 40. Then the person will not know where to put in their age. Then we talked about the neutral responses. We talked about the low response rate for emails. Then validity and reliability cannot be tested. If that's not possible, that could be a problem. If your sample is too small, it could be a problem. And people don't filling in questions could be a problem. Okay, and then there's just the whole process. So first you establish your goals, research questions, and hypothesis. Then you have your methodology. We talked about this. We talked about research approach, design, experiments. Then we remember the validity and the reliability. And then this research consistency matrix is very important to align everything. We looked at sampling. Then you have your gathering of your data. After all of this is finished, the format must be in the correct manner we talked about. Then the statistical packages, the data analysis cycle we talked about. There's the whole data analysis cycle. Again, To recap, yes.
You can also use those that structure to kind of help you prepare your proposal. And some of it will feed into your specific chapters for your thesis.
Yeah. Yes. Of course, there's the research methodology. Yeah.
Good thing that wasn't.
I think the 2.4 is out here. That's validity and reliability. Just put in the 2.4 as reliability and validity. Okay. Then, okay, that's the data analysis cycle we talked about, and the issue interpretation and write-up. So just put in 2.4, just don't forget to put in here, there's validity and reliability of the questionnaire.
You can send us an updated slideshow if you want.
Okay, I can just send that to you. Okay, and then just to conclude, make sure samples about your sampling and your questionnaire. That's the main things we talked about. And it must be valid and reliable, and you must be sure what techniques you want to use to answer your research questions. Okay, is there any questions?
Thank you.
Okay.
There's one question here.
Yes.
Yes, my question is this. With regards to the statistical packages, what is the advantage of capturing the responses in Excel before you now go to the statistical package and then import what you have captured there? Why not just capture it straight into the statistical package?
Okay, you can, for instance, capture it straight into SPSS, for instance, but it's much quicker to capture it in Excel than in SPSS, I think. I tried it, it's quicker, but usually the process is that capturing is separate from the analysis. Sometimes other people capture it for you. It's not you yourself, or that people don't have access to the statistical package, then they just do the capturing. But you can do it straight into, say, SPSS if you want to. But it's quicker to type it in Excel, I think, than in SPSS. The typing is quicker. But you can do that. You can do it directly in SPSS also. It just takes a bit more time when you do the typing.
So
Okay.
Henny, a
Yes.
question from me. You've given your contact details. What sort of services can you, as a company, offer the students?
What you can do is you can go to the website. I don't do full students anymore. I just do hourly consultations online. And then there's online workshops that will be presented from August that will be about this whole process here, but in detail, with videos and everything, if you're interested in that, or somebody that wants to have more information. So that videos will explain everything in detail. It's about 40 lessons, I think, in the one workshop.
That's good.
Okay.
Thanks so much. Any more questions?
I'll get the slides for
Oh, the slides is already in your inbox. There's a question?
There's a question. So I think this presentation works very best for those of us doing the quantitative, especially me. I really appreciate every bit of it. It's an eye-opener. Yes. So how do we, when we apply for the ethical clearance, you need to submit this, but you know that what you submitted is not up to you. So I want to structure it well to suit the SEMBE. Is there any way we can...
For the ethical clearance?
Yes.
So, okay, in terms of the ethical clearance, Henny, if you don't mind if I answer, it is, in most cases, it's perfectly fine if there's minor adjustments after you've done your ethical clearance and you realize, I'm going to use a slightly different way to analyze my data, whatever it is. But the problem with ethics is when you start asking people different interview questions, or you have a totally different survey instrument, then you have to reapply. So there's a fine line, you know.
Yeah.
There's always minor changes, and there's always the important thing of remember that ethics is about how you treat your participants.
Yeah.
So if there's no major changes there, and your topic research questions in general doesn't change really, you know, minor change might take place, but if it doesn't really change, it's fine.
Okay. But is there any way, Ms. Gaba, you can support us to maybe reshape the question to suit someone? Is there any way you can support us in that regard?
Okay. Any way I can support?
Yes.
Sorry, I missed the question.
Is there any way you can support us, like structuring the research questionnaires and the analysis?
Yes. Yeah. So the question. Yeah.
No, you can talk.
No, you can. Did you get the question?
Yeah, I think so. Anyway, I can support you with the structuring of the questionnaires.
Yes, and the analysis.
Yeah. Okay. Like I said, I just do hourly consultation, so I can do that. But what you can do is you can maybe make a group if you want to. So say if you do an hourly consultation, I do it on Zoom, and you are 2 or 3, then it's much cheaper for you. Because then you're free of you together, and we have an hourly consultation, something like that.
All right.
Yeah, if you're interested, or you can do the workshop if you want to. But I think what will help is if you make a group of say 2 or 3 people together, and we Zoom, all of us Zoom in one session, and then you split the cost of one session.
All right. Sure.
Okay, so any thanks from our side?
Okay.
It was really useful and detailed. And thanks. But you will share the link for the video?
Yeah, thank you. Yeah, what I'll do is I'll put it on YouTube or somewhere. Yeah.
Okay. Thanks so much.
Okay. Okay, thank you. Okay, good luck there.